And this brings us to the so-called SOFAR channel, sound fixing and ranging channel. Okay, let's go back to the warm water regions in the ocean. Okay, so where we have a sound speed minimum at 1,000 meters, and that's shown here on the in the upper panel of these sketches. Okay, and so the rule that the sound rays bend towards the regions where you have a lower sound speed means that you get always bending south path, which tends to actually propagate along the minimum at 1,000 meters. Okay, so this is the sound channel, the SOFA channel, and that's used by whales and other marine mammals for communication. Okay, so because you can effectively communicate in that area, so very fast and over long distances. Okay? So in polar regions, it's different. Okay? In polar regions, and this is now shown in the typical profile shown here in the lower panel, okay, because you have in polar regions you have cold water sitting near the surface. It's actually supported by a low salinity coming from the meltwater influences, and that gives you a maximum at 100 meters or so. Okay, because the temperature profile is different. And you have cold water near the surface, not warm water. Okay, so now it shows you if you emit a sound, say from the surface, okay, the sound rays actually are bending away from this zone of the high sound speed, and you can see that they are bending away and they create a shadow zone, and you can hide in this shadow zone. You also can't hear anything in this shadow zone. Okay, so you get this bending away from maximum sound speeds, and that's a typical feature of polar regions.